Hello everyone again. Today we will see a very interesting task which is called Koko Eating Bananas. It's a medium level task. So let's check the conditions. So you are given an integer array piles where piles I is the number of bananas in the if pile and an integer age representing the total hours available. So Koko wants to find the minimum integer velocity k, bananas per hour, such that she can eat all bananas within 8 hours. And rules, we have some rules here too, so let's check them. So if the pile has fewer than k bananas, she eats them all and cannot eat any more bananas during that hour. And the second rule is that she cannot move to the next pile until the next hour starts. And below we have an example where we have an array with bananas, and age is hour until guards will return, and in that case the output should be 4 because if we choose 4 bananas per hour, it means that for the first pile we will need 1 hour, for the second pile we will need 2 hours because 4 plus 4 it's 8, so we have inside 6, which is fine. Then for the next pile where we have 7 bananas we will also need 2 hours, and for 11 bananas we will need 3 hours, which in total is equal to 8. It's a perfect number in our case. So that's the idea. Now let's go and answer to some questions. I know that maybe this task is a little bit confusing, so let's check the questions. So what are we searching for? Why binary search we need to use here, and what pattern can we use? Yeah, I think you already know. So let's answer these 3 questions. So what are we searching for? The minimum integer k, which is speed, such that the sum of hours for all piles is less than or equal to age. Why binary search? The time function is monotonic. The higher the speed, the less time is required. This allows us to discard half of the speed range at each step. And what pattern can we use here? So we can use binary search on answer. So we search for the value of the answer itself in the range from 1 to the maximum in the piles, rather than an index in the array. So that's it what we have. Maybe again it's confusing and maybe you don't understand what exactly you need to do, but I think it will be a little bit clear while we will solve this task in the code. So let's move to the next step, where I will try to implement this task. So first of all, let's create our method. So we need to return our bananas per hour, so it will be an integer, and let's call the method find optimal speed, let's say. And we will have 2 arguments here. So the first argument will be our array with bananas, our piles, and the second one will be the hour until guards will return. Okay, perfect. Yes, so now let's create. So first of all, what we need to search in the first tab, yeah? So now I want to search for the maximum number of bananas inside our piles, because it doesn't make any sense to divide by greater number our bananas than we have in our array. So for that, I will need a for loop, because I will need initially to iterate through all array in order to know the highest number. Yeah, now let's declare a variable max bananas, which will be equal to 0 initially, and then we will go through our array and we will search for the maximum value. Okay, now let's create two variables which we create in every task where we use binary search. It will be left and right boundaries. So let's do this. Yeah, you may ask me, so why left is equal to 0, yeah, and why right is equal to maximum bananas? Because our boundaries is a number between 1 and maximum number of bananas, which represents how much bananas Koko can eat per hour. Yeah, so we need to find the minimum number which can suit to our conditions, and this number is between 1 and maximum bananas. So we will not use binary search inside our array of piles, yeah, with our bananas. We will use binary search in these boundaries between 1 and maximum bananas, and we will search for the optimal solution. Now let's create while, which will help us to iterate through our boundaries. And here we will put left is less than right. All right, and now inside let's calculate element from the middle of this boundary, so between 1 and 11. Okay, and also I think that we will need to create another method which we will use in order to check this number, so this hour, in the first iteration it will be the number from the middle, so let's say 6, yeah, if 6 bananas per hour suit to our condition. So if we will have this speed, Koko will eat bananas until all guards will return. So let's create this method to private static, and here we will use boolean, yeah, because we want to return true or false. And let's call it can continue. Okay, like argument here we will put our integers, our piles, let's say, the number which is the current number, so in our case let's say it's 6, yeah, the middle number, and hours until guards will return. Okay, and now we need the logic which will help us to check if the current hour suits to our conditions. So Yeah, so let's create a for loop in order to iterate through our piles. Also, let's create a variable where we will have a sum of hours. Okay, and now let's calculate how much time we will need, how much hours, if Koko eats 6 bananas per hours, let's say. Plus k minus 1 divided by k. And why do I use this formula? Because I want to round my number in the greater side. Because in Java, if for example we divide 3 by 2, it means that because we use int variable, we will store only 1. But in our case, I want to round it by the greater side, so I want it in that case to be 2. So because of that, I use this formula, because by default it will round to less side, less value. And now let's check in this for if the current result, some hours, is greater than hours. We will return false. And here some hours is less or equal to hours, then in that case it will return true. Okay, so we have this method which helps us to check if the current hour which we have selected, which is middle value, is suitable, then it will return true. But it doesn't mean that it's the best option, because it can be suitable. Yeah, we can eat all bananas by the time while guards will return, but it can be too fast. Yeah, so we need to find the last best option, so for that we will need to continue to iterate to our options and to check if we have a better one. So for that we created this while loop. So here we can now use this method, can continue. Here we send our files, current hour and hours. And if we can continue, that means that we can initialize to update our value to be equal to mid, or otherwise we will need to change the left value, and it will be equal to mid plus 1. And at the end we will return left. Okay, so it looks good. So now let's test this solution. So let's create public static void main, system out println. Let's call our method find optimal solution. Yeah, find optimal speed, and here we will initialize an array with bananas. Let's say 3, 6, 7 and 11, like in the condition, and when our guards will return. So let's check how does it work. Yeah, so it's 4, like in the condition, if you remember. So it looks good. Now let's go and try to analyze the solution. So the time complexity is O(n) log m, where n is the number of piles one pass through the array in the check function, and log m is the number of binary search steps over the speed range, where m is maximum number of bananas in a single pile. And the space complexity is O(1), where we only use a fixed number of variables like left and right, boundaries, mid value, sum of hours, regardless of the input size. So it's pretty good complexity. I think this exercise helped you better understand how binary search can be used in different cases, not only in the initial array, like in this example. So I hope we will see in the next video. Bye.